let's just draw the spacer in line with here. 150 long by 12, tapped at 20mm both ends. So we just draw a rectangle. So there's a centre mark. The spacer is 150 by 12. Done. And we'll go to our M12 by 1.75. So we'll need to come in half of 1.75 is 0.875. Let me just set that to chain. 0.875. Now I'm going to offset that because we're coming in 20mm. I'll just draw one end and then I'll worry about the other one later. Just looking at the dimensions, M12 by 20, which means it's 20 deep. So we just want a single, and we want it by 20mm across to there. And now we're going to select that one and his two friends and turn those into a thin line. While I'm at it, let me turn that into a centre mark. That one there is a thin line. This is the thread form I'm drawing. That comes up at 30 degrees. 30. This one comes down at 30. I'll do that. That of course gets extended out like so. This now gets trimmed across and cleaned up. So now I'll just select all my work on this end. So I'll select them first, delete them, select all my work on this end and just reflect it. There it is, miles outside. And now I just move it across. And now I can delete the thread form that's not there. So there's the center pin drawn. I need a 12mm ID pipe, 100 long. So let's just go to how thick is a standard pipe with 12mm inside? Metal, steel. Normal dimensions of steel pipe, Atlas steels, carbon steel, SCED 10 would do it. What a schedule means, the bigger the number, the more pressure it takes. 2 times 1.65 is 3.3mm, so that's going to be around about 13.5mm internally. So we're going to be 17mm on the outside. I need something that's just a touch over 2.5 to take it back down to 12mm. Look, that's going to have to do it. 17.1 outside diameter with a wall thickness of 2.31 mils. So we're going to go from here 17.1 millimeters outside diameter by 100 long with a wall thickness of 2.35 mils from memory, 2.31 mils. So 2.31. Okay, so there is our pipe. Let's now section it. The bolt, it's really a stud it is because it's threaded both ends. The stud is not sectioned. Fasteners are not sectioned when they're cylindrical in cross section. The pipe, however, is. And the pipe is section, let's pick a different number, 120. Done. So there is almost every single part of our pulley drawn. The only thing I need to do is to draw up the nuts for this. To draw up the nut, let's just make a line here. It is 12 mil nominal diameter. Nuts are 0.8 thick. 0.8 times 12 is 9.6 mil. The offset on this, I'll use the computer to do it. I'm going to offset that 0.45 diameters. 0.45 times 12 is 5.4. That goes there, that goes there, and that's there, and that's there, and that is done. Okay, so there's our nut, and we'll have to put a washer on that as well. Once again, I don't think you want the cheek plate falling apart, so we'll draw in a spring washer, which is drawn the same as a standard washer. There you go, I've got the center mark picked. Washers are 2 times diameter, 2 times 12 is, in this case, 24 mil, and they are 0.15 thicknesses. The answer is 3.6, but let's type it in. 0.15 times 12 equals, oh, I was wrong, 1.8, because I'm glad I triple checked. There's the washer. To make it into a spring washer, that is just a bog standard mild steel engineering washer. To make it into a spring washer, let's just draw a line across at 45 degrees, like so. There is a spring washer drawn. I'll just mirror them. Should be able to just pick a mirror point now quite happily. Done. So there's a spring washer. There's everything, and we are drawn.